This is lesson 7.8, using trig ratios, tangent. So first of all, trig ratios is a short way of saying trigonometric ratios, and our trigonometric ratios are used in the study of trigonometry, which is the study of how sides and angles of a triangle relate to each other. We're going to not only learn tangent, but also sine and cosine. Now, to do this, we're going to need some information about how to name the sides of a right triangle based on a given angle. We're going to call that angle our reference angle. Reference angle. And that is another way of saying what angle are you referring to? So reference angle, referring to. So let's just do this based on angle B for a moment. Based on angle B, let's name our sides with these three terms: hypotenuse, opposite, and adjacent. Well, we know that across from the right angle is our hypotenuse. I'm going to use HYP right now for hypotenuse, but later in the lesson, I'll talk about it just as capital H. That's the hypotenuse. Now, based on our reference angle, angle B, the side opposite angle B is this side, and we call that the opposite side, which then leaves only one side, right? We have hypotenuse and opposite, only leaves one side to be the adjacent side. Adjacent means next to. So those are our three labels for reference angle B: the hypotenuse, the opposite side, and the adjacent side. I can name those here. Segment CB is our hypotenuse, opposite is segment CA, and adjacent is segment BA. Now, if we had done that work based on angle C instead, what would happen is that, well, you just get a different answer, right? So based on angle C, is the hypotenuse still right here? Yes, it is. The hypotenuse doesn't change because the hypotenuse is always across from the right angle. But if our angle C is now our reference angle, now across from that is our opposite. So that's opposite now for the other reference angle. So that's segment BA. And then adjacent will be the one that is, again, next to the angle we're talking about, so CA. Notice that what happens is these just switch around based on the two different reference angles. We will never use our right angle as our reference angle because that would make the hypotenuse be the same as the opposite, and that doesn't work. More on this as we go throughout the lesson. So why do we need to know about labeling the sides like we just did? Well, we are going to be talking about three trig ratios in this chapter, and they are called sine, cosine, and tangent. This lesson is obviously focusing on the tangent ratio, as the heading of the lesson said. And so the tangent ratio is a comparison of two numbers from this right triangle. Now let's go ahead and label our sides like we did on the previous screen. Across from our right angle is always the hypotenuse, HYP, or later we'll just call it H for hypotenuse. And we are, if you look right here, we're talking about the tangent of angle A. Okay, so that's our reference angle. That tells us what angle we're referring to. So I'm going to put an arc here in that angle because that's the angle we are referring to. Now, based on that angle, like we did in the previous screen, we know that the opposite side is over here, opposite of angle A. And if that's hypotenuse and opposite, then we know that this is the adjacent side. Okay, now that those are labeled, we're going to look at what is the tangent ratio for A. Well, the tangent ratio is always the opposite side over the adjacent side. All right, the opposite over adjacent. It never changes. Tangent is always opposite in the numerator, adjacent in the denominator. And so we're going to go ahead and say the opposite side here is BC. So segment BC would go here if we knew the length of that. And the adjacent side is CA, and we'd put the length of that in the denominator. Now let's look at some examples because it's going to help you understand why we're doing this. Okay, so we're just going to practice writing the tangent ratio before we get into why this is super useful. So we're trying to find the tangent, oops, sorry about that. We're going to find the tangent ratio for angle S. Well, we know the tangent ratio of a reference angle is always the opposite side of the triangle over the adjacent side of the triangle. So based on angle S right here, the opposite side is 60, right? Let's go back through this quick. Across from the right angle is the hypotenuse. And across from the angle of reference is the opposite. And then the remaining side is the adjacent. So if I wanted to say the tangent of angle S, the reference angle S right here, we'd say the opposite is 60 and the adjacent is 25. And now we can do the same thing for the tangent ratio for R. So we're just referring to a different reference angle. We're still doing the opposite over the adjacent. But now, again, if we're talking about referring to angle R right here, this is still the hypotenuse, but the opposite side is over here, and the adjacent side is here. So now opposite is 25, and adjacent is 60. So just keep in mind, you always have to know which angle you're referring to and use opposite over adjacent. Okay, so why is it helpful to know this thing called the tangent ratio? I'm going to show you in this exploration. So if I write tan equals O over A, I want you to think about how that is reminding us that the tangent ratio of a reference angle is the opposite side over the adjacent side. We are going to find the tangent ratio for angle C in each of these triangles. Now, there is no C labeled here, so let's go ahead and do that. This is angle C, the 37-degree angle. Okay, so we are going to write our fraction opposite over adjacent for each of these triangles. To do that, I want to remind you, we're going to go ahead and put in some labels. I'm going to put, on the previous screen, I had written HYP for hypotenuse, OPP for opposite, and ADJ for adjacent. A lot of times we will simplify that even further and put an H for the hypotenuse. Again, notice it's across from the 90-degree angle. And based on our reference angle of 37, opposite is over here. So I'm going to put an O here for opposite, and the remaining side is our adjacent side. I'm going to do that for each triangle. Here's my hypotenuse, opposite of the 37-degree angle, and this must be the adjacent. This is the hypotenuse across from the right angle. Then we've got opposite and adjacent. So now I'm going to write my ratios. Opposite of this triangle is 3.1. It's right here. Adjacent is 4.09. What's the next triangle? Opposite is 3.78. Adjacent is 4.96. How about the third triangle? 8.42 is the opposite. 11.26 is the adjacent. Now, what does that help us see? Well, that will become apparent after we simplify these fractions into a decimal. 3.1 divided by 4.09 gives us 0.76. 3.78 divided by 4.96 gives us 0.76. 8.42 divided by 11.26 gives us 0.75. And these I just rounded to 2 decimal places. Just a reminder, we're going to be using 3 decimal places in our work in this chapter. But I wanted to show you that this turns out to be, as you can see, the same or approximately the same value every time we do opposite over adjacent, as long as that angle was the same measure for each triangle. That is how tangent helps us. That's how trig ratios help us, because we know there's always a consistent ratio between 2 sides. So every angle measurement has its own tangent ratio that never changes, so you can use these ratios to set up and solve proportions. Okay, so let's see why tangent helps us. If we have an example right here, and we're trying to find this side, x here, the length of the side, and we know this is 17, and we don't know the hypotenuse, there is no knowledge that you have at this point that will help you find that side length. Well, guess what? Trig will do it. So here is what I want to put on the top of our screen here. We're going to use the tangent ratio. A lot of times we use theta, which is a Greek letter. It looks like that. To represent an angle measure. So tangent of theta is opposite over adjacent. So that is our tangent ratio. So let's see how that helps us. Well, if this is our 31-degree angle, we're going to use that as our reference angle. Since it's written in the diagram, we know that angle is 31. Based on that angle, let's label our sides. We know across from the right angle is our hypotenuse. Across from our reference angle is our opposite side, and the remaining side is our adjacent side. Because we know this is 17 and it's our opposite side, and this is what we're trying to find, and it's our adjacent side, we need to use a ratio that uses these two values, the one we're trying to find and the one we know, and that ratio will be opposite over adjacent. So we are going to use the tangent ratio. We're going to write tangent of our reference angle, which is 31, is equal to, as we know, the opposite side on top and the adjacent side on the denominator. So opposite is 17 and adjacent is x. So I'll write a 17 here for my opposite side and an x here for my adjacent side. Now we have an equation that we can solve. And the way I recommend you solve this is by turning this side into a fraction. You can always put a number over 1. I want to point out this is just a number. Tangent of 31 you can actually find by using a trig table or your calculator. Now I'm not going to do that yet, but we're going to say tangent of 31, which is a value, is over 1 is equal to 17 over x. This is a proportion, another reason we were practicing that recently, and we can cross multiply. 17 times 1 is 17. The tangent of 31 times x, we are going to write just like that. We're going to write tangent of 31 times x. Now, these two things are being multiplied. We undo that by dividing. So I'm going to divide by the tangent of 31 on the right, and I'm going to divide by the tangent of 31 on the left. The tangent of 31 cancels on the right-hand side of the equation, and we're left with x equals 17 divided by tangent of 31. Now, this is an important thing today. I want you to grab a calculator, and I want you to do this math with me here. Do 17 divided by the tangent. There is a tangent button somewhere on your calculator, tangent of 31, and hit enter. What you should get is 28.293 when rounded correctly. It is very important that if that is not what you get, your calculator is not in the correct mode. It's in radians instead of degrees. You need to fix that, and I have videos provided in Schoology for you to learn how, or talk to me in class, or both. If you don't get that value, none of your work is going to work out. All right, so 28.293, check that on your calculator. That's how we solve and find a missing side of a right triangle if we have an angle measure we know. Let's do the second one. Again, we have a reference angle right here because we know it's 11 degrees. Based on that angle, I'm going to name my sides hypotenuse, opposite, and adjacent. I now realize that I'm trying to find the opposite side, and I know the adjacent side, and I know the ratio I need to use is tangent. That clarification will make more sense after you learn sine and cosine. So tangent of the 11-degree angle is the opposite side, which is x, over the adjacent, which is 24, right? Opposite and adjacent. When we solve this proportion, it's actually a little easier. When we put that over 1 and we cross multiply, it's going to come out a little easier. So x times 1 is x, and then tangent of 11 times 24, tangent of 11 times 24. Again, check with your calculator. If you type in right now tan 11, enter, times 24, you should get 4.665. Let me know again if you're not getting those values. It's very important. All right, this lesson is getting a little long, so I'll make this one kind of quick. We have just a simple real life situation of, can I find the height of this lighthouse if I have some information about it? If I'm standing 100 feet away from the lighthouse center, and I want to find the height of it, if I can measure that angle, and there are devices out there that help you measure the angle of elevation, that's called. And if we have it as 62 degrees, again, we're going to label our triangle. This is my hypotenuse. It's across from my right angle. Across from the reference angle is our opposite side, and the other side is adjacent. So tangent of the 62-degree reference angle is opposite, which is h, over adjacent, which is 100. Again, cross multiply to solve, and check to see if your answer is the same as mine. Again, checking calculator's mode here as we go. And what you should get here is that the lighthouse is 188.073 feet.